All right, section 11.1 is the circumference and arc length. So the circumference of a circle is the distance around the circle. So the circumference of a circle is equal to pi times the diameter. Remember, the diameter is all the way across the circle, or C is equal to 2 pi times r, where r is the radius. And again, remember, the radius is actually half the diameter. Okay, so well, it just says that where d is the diameter of the radius, and where d is the diameter of the circle, and r is the radius of the circle. So here, I did put this in here because it probably will be important to us here. But throughout this chapter, you should use the pi key on your calculator, then round to the hundredths place, which is two places after the decimal, unless instructed otherwise. My reason for putting that in is because, remember, when we do the homework on the website, it's pretty particular. So try to make sure that you do that, okay? So example 1, find each indicated measure, a circumference of a circle with a radius of 11 inches. So if it's the radius, we know we're going to use C is equal to 2 pi r. Okay, and on this one here, we know that our radius is equal to 11 inches. And again, you'll plug that into your calculator using the pi. And when you do that, you'll get that C is approximately equal to 69 and 1200ths inches. Remember, on these ones, if it gives you units, make sure you put in the units, unless, of course, the Big Ideas already does it for you. Sometimes I notice they do that, right? And then now the second one was find the radius of a circle with the circumference of 4 millimeters. So again, we're still going to use C is equal to 2 pi r. In this case here, we're looking for the r, but we know that the C is equal to 4 millimeters. So then we're going to take 2 pi times r. Remember now, to get r by itself, we're going to divide both sides by 2 pi. And if we do that, we'll see that we'll get to r is equal, again, if we put 4 divided by 2 pi, again, you might want to put this in parentheses, all right? When you're putting it in your calculator, it depends on your calculator a lot of times. But if you do that, then you'll get to r is equal to 64 hundredths. And again, that would be millimeters, which we could write as little mm. Okay, so that should still be something that's review. Arc length, on the other hand, is probably something new to us. So an arc length is a proportion of the circumference of a circle. You can use the measure of the arc in degrees to find its arc length in linear units. So, excuse me, arc length. In a circle, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. All right. So what we're talking about here is our arc here. This would be our length that we're talking about. When we're talking about the measure of the angle, we would be talking about what is in here. All right. And usually they'll either give us that or that'll be something we have to solve for. All right. And basically what they're saying here is that we're going to take our arc length of AB, and then we can multiply both sides by 2 pi r, so we get the arc length all by itself. Remember, what is 2 pi r also? It is also our circumference. So sometimes you might just have to put the C there, okay? So our last example here, we have 3 quick ones here. So find each indicated measure. A, the arc length of PR. So here's our PR. All right, and I'm just going to keep writing this for you. So the arc length of PR, right? And they put an arc over it, is equal to the measure of the degrees of PR divided by 360 degrees times 2 pi r. Okay, so looking at our diagram here, we can again then say that it is equal to, I'm not going to rewrite arc length of PR every single time for you, but we know that the measure of the angle is here. So we're going to say it's 100 over 360 degrees times 2 pi, and our radius on this example is 12. So it's 12 inches. All right. So if we plug all of that into our calculator, again, you should get that the arc length of PR is approximately 20.94, and we were in inches in this case. All right. So part B, the circumference of circle P. So remember, circumference is the distance around the circle. So we're looking at all of that. All right. So again, arc length. Here, let me use a different color. So I'm of QR is equal to the measure of the degrees of QR over 360 times, now I would say 2 pi r, but they're asking us to find the circumference, so I'm just going to put C there now. All right. So again, I'm going to plug in everything that I know. I know that the arc length here is 6.5. All right. I'm going to say 6.5 is equal to, we know that the measure is 130 divided by 360. And again, since we said circumference, we're not going to worry about 2 pi r. We're just going to put the letter C. So now remember, to solve for C, since I have this as a fraction here, I'm going to be multiplying it by the reciprocal. Because remember, that's going to make all of that just be 1. So we'll have C is equal to, and again, if I multiply all of this together, all right, and I put it equal, I didn't put approximately, because when you plug it into the equation exactly as it is, it does end up being exactly 18 meters. And then finally, our last example, they want us to find the measure of the arc. So what we need now is we do need the measure there. So again, we're still going to use our same formula. So in this case, our arc length of JK is equal to, and sorry, I'm running out of room there. I tried to put all 3 of them here on here for you. So I would only have to use one sheet of paper, is equal to the measure of the arc JK. It's in degrees over 360 times 2 pi r. All right, so now we're going to plug in what we know. We know that our arc length, which is here, is 21. So here, let me go ahead and use a different color, since I did use the pink here. So I'm going to say then that 21 is equal to, we do not know what the measure of JK is, but it's divided by 360 times 2 pi, And then we know our radius is 14.32. Okay, so now again, I want you to kind of think, what are you going to do here? You are going to multiply both sides by 360, right? Because that's going to make those go away. And then we're going to take all of this and we're going to divide it. So that would be 2 pi times 14.32. Okay, so now we got the measure by itself. So we got the measure of JK is equal to, again, if I plug all of this in together, it will give me approximately 84 degrees. And that's it, ladies and gentlemen. All right, pretty straightforward. Nice one to come back to.